Good evening, everyone. Today we are going to talk about Blazor, which is an incredible framework that you can use to develop rich and interactive client-side web UIs with C# instead of JavaScript, something a lot of developers and apparently their leaders have been dreaming of. In this webinar, first you will learn what Blazor actually is and how it works. Next, you will learn why you should use Blazor. You will also learn how to get your environment ready and how to create your first Blazor app. And finally, you will learn about different architecture types that you can use to develop Blazor applications. Along the way, I'll show you all these concepts through some demos and practicals. But before we start, I have a poll for all the audience. So we want to know if your organization is using Blazor in production. So it will just take a couple of clicks to give the answer. So I'll wait for 30 seconds and let's see the responses. Yeah, you should be able to see the poll on your screen now. Okay, I have the poll results and it's actually really good to see that 63% of you are using Blazor in production environment. So that is really interesting. And for those who are not using, let's learn about it and how it can be used in the organization for different purposes. Okay. So before we dive into Blazor, let's talk about web development in general. Usually, you create some code that runs on server somewhere. This can be any type of code like Java code, .NET, Node.js, or any other type of server framework. In the case of web development, you want to show something in a browser. And nowadays, you would use a framework like Angular, Vue, or React to create your UI. These frameworks are great at developing fast and interactive UIs. This is fine, but it does mean that there is a fundamental disconnect. You can't use the language that you use for your server-side code to create UIs for the browser. So you cannot reuse your skill set. And some of these UI frameworks have a pretty steep learning curve. But with Blazor, now you can. In fact, you can run any type of code in a browser using WebAssembly. WebAssembly is a way to run bytecode in a browser inside the JavaScript runtime sandbox. You can compile any type of code like C++ or C#.NET to WebAssembly and run it in a browser at near native speed without need for a plugin. Blazor works by having a .NET runtime that is compiled into WebAssembly bytecode. How cool is this, right? Now let's look at why we should use Blazor. First, because if we use Blazor, we can run our app in any browser, including mobile ones. Because WebAssembly is part of all major browsers. We are no longer dependent on plugins like we were back in the days with Flash and Silverlight. Yeah, I know it was painful. And we use Blazor because it allows us to reuse our C# skills. And unlike JavaScript, which is a dynamic scripting language, C# is strongly typed, which means that you can catch errors at compile time instead of at runtime. We can reuse our existing common libraries and also almost all public NuGet packages across the full stack. Another reason to use Blazor is because it is fast. As it runs on WebAssembly in the browser, it can run at near native speed. And finally, you should use Blazor because it is a Microsoft framework, which means that you get all the incredible tooling to work with. For instance, you can create a Blazor app with Visual Studio along with IntelliSense, IntelliCode, debugging support, hot reload, and all other features. It helps you to be very productive. A Blazor application consists out of things that make up a website like HTML, CSS, and C Sharp. Blazor apps are built using Razor components. These are the files that contain C Sharp and HTML and look like this on the right hand side where we have declared a Blazor component. This component has a button that triggers the on-click method here. So this is what code in Blazor app looks like. And components are reusable blocks that you can use in your application. So you see HTML and the function logic is written inside a C Sharp. And you can nest components like in this example. In the left hand side, if you see index.razor, and in this case, index component is designated as a page that you can navigate to, inside which there is a dialog component embedded. So how do we get this code to run in a browser? When a Blazor application is built, it produces assemblies among other things. These DLLs are .NET standard DLLs that you can use in any other compatible application. In the browser, these DLLs can be run by a .NET runtime. This .NET runtime is a version that is compiled into WebAssembly bytecode and has the WebAssembly file extension that is .wasm. And this .NET runtime runs on WebAssembly inside the browser. Okay. Now inside the browser, WebAssembly runs in the JavaScript sandbox just like JavaScript code does. This is because UI DOM is still being rendered inside the using the JavaScript sandbox. And because all of this runs inside JavaScript runtime, your application can access capabilities of the browser like WebSockets, the File API, and the Document Object Model or DOM. Ways to develop the Blazor application. We have different ways and tools to develop the application. We can develop Blazor using Visual Studio. We can also develop it using Visual Studio Code, or developers can use .NET Core CLI and editor or IDE of their preferred choice to develop Blazor application. Now let's talk about different Blazor architecture types. Okay. There are different architectures that you can use to build your Blazor app. Let's explore them and see which one you should use when. Okay, so let's start with the Blazor WebAssembly. Then we will look into Blazor server type. Then we have a Blazor hybrid, which can be used for developing multi-platform native application UIs. And then recently, Microsoft announced a new type that supersedes everyone. Let's dive in. First one is the Blazor WebAssembly. This is the Blazor that we were talking about so far. So it runs on the client in the browser on WebAssembly. When the app loads, it downloads everything that it needs to the browser. It downloads the complete .NET runtime and the garbage collector that is converted into WebAssembly bytecode. This type of Blazor application doesn't need a connection to server. It just needs to load into the browser and that's it. Now let's look at a demo of the WebAssembly application. In Visual Studio, we have a ready-made templates to create Blazor applications of different types. We will start with the WebAssembly. Okay. We have just selected the template. Click on next. Here, let's keep the default settings as it is. One thing I wanted to mention is we can also host this Blazor WebAssembly app inside a ASP.NET Core, which can run on the Azure App Service. or we can make it run as a standalone app. So let's run it as a standalone app for the demo purpose. And now we have a bootstrap project for the Blazor WebAssembly. Here, if you see, we have Blazor components. We have startup files, which will look into it in the deep later. But first, let me show you how this app looks. Okay, so now what we are going to do is we are going to simulate a first time load of the Blazor application, using which we can know how the first time load looks like in the browser, in the client's browser. Okay, so when we are loading it, if you see, browser has downloaded all the DLLs along with the .NET runtime, net standard DLL. Okay, and some WASM files it has also downloaded. If you see into the console, we can see that it has loaded all the resources it needs from the network. And on the subsequent runs, what it does is it will load these resources from the cache instead of going back and forth to the server. So here, if you see now, let's go to the network tab, clear everything. And if I click on this button, the counter gets incremented, even though nothing is going back to the server. Okay, so there is no communication happening, and everything is working on the client side itself using C# code. So that was the small demo of the Blazor WebAssembly. Now let's look at the advantages and downsides of this type of architecture. So with Blazor WebAssembly, as we have talked earlier, it gives us a near native performance due to the WebAssembly support, which is a bytecode version. Also, you can work offline using the WebAssembly. No server hosting is needed. That means you can use technology to serve static files. You can use, for example, Azure Blob Storage to host WebAssembly application so that there is no cost incurred for the compute resources. Also, you can use client-side resources to do all the interaction and logic handling. And last but not least is it runs in all the modern browser without any external plugin needed. Apart from benefits, there are some downsides in this architecture type. Okay, the first one is that you are restricted to the capabilities of the browser. Your code runs in a sandbox and you have to behave within the rules of that sandbox. We just said that this can be a benefit, but it can also be a downside, because if you need to do compute intensive things, the client side can be a little bit restrictive. Blazor WebAssembly downloads everything to the browser, including the .NET runtime, and this takes time, so it might result in longer load time for the first time. And when you need to store a key to connect to an API, you can only store it in a file that is downloaded to the client. So there can be a security concern when you are downloading the secrets on the client side. Now let's look at the next type of architecture and how it can overcome some of the downsides that we just seen. Okay. So in the Blazor server, the Blazor app runs inside ASP.NET website that runs on the .NET runtime. This website then serves the Blazor website and loads Blazor through a WebSocket connection that it uses through SignalR. Using this, UI updates are streamed from the server in real time. And by the way, code in Blazor server application can also interact with JavaScript, just like code in Blazor WebAssembly can. Basically, you can use Blazor server for thin client scenarios where it uses a real-time WebSocket connection through SignalR framework to update UI elements. Let's have a look at how the Blazor server application looks and works. So let's create Blazor server web application. For that, we will choose Blazor server template. Click on next. Let all the default settings be there. Let's just click on create. Now, if you see everything, all the Blazor components are still the same that we have seen in the WebAssembly. Just the deployment or runtime gets different when we are running this application. So let's run this application and analyze how it looks in the real work. And again here we will simulate the first time load. So let's look at the WebSocket tab and let's load the application. Once the application is loaded, you can see that it has created a WebSocket connection with the server, that is with the backend. Okay, here are all the messages that are being transferred. Now let's go to the counter page, counter component, and try to increment the count. If you see, it's going back to the server and getting the data from the server. The server is updating the UI basically here using the constant WebSocket connection. So this is how the Blazor server works in the background using the socket connection. Inside the fetch data also, if you can see, it has fetched all the data directly from the server. Now that we have seen how the Blazor server works, let's talk about its pros and cons. Everything runs on the server, so there is no need to download the .NET runtime or all the assemblies of the app, and due to which it loads fast even for the first time. And since you run on the server, you have access to the full capabilities of the ASP.NET framework. You can even use multi-threading and all other aspects that the .NET framework provides. Also, WebAssembly is not required to run the app, which can be handy in thin client scenarios. From the downsides, you need a connection to the server, so you cannot work offline. Also, you need a server to run this, so you need to maintain and secure that server. You also need to take into consideration the scalability costs when you are hosting the server. And finally, because you constantly go back to the server for UI updates, you will have a higher latency, which can slow down the application interaction. Let's move on to the third type, which is Blazor Hybrid. Blazor Hybrid is a way to build interactive UI with which allows you to blend desktop and mobile native client framework with .NET and Blazor. So let's have a look at a Blazor Hybrid and how it works in a native environment. And until it builds, let's talk about this Blazor Hybrid. Okay, so in this Blazor Hybrid app, Razor components run natively on the device, and components render to an embedded web view control through a local interrupt channel. That means components don't run in the browser, and WebAssembly is not involved at all. So you get a pure native experience, even though you are reusing your components. So let's have a look at the Blazor Hybrid application. So I have created a Blazor application, and for demo purpose, I have Android simulator. So we are running this application inside the Android as a native app. So if you see on the left hand side, it is creating all the APK files that are required for the application to run inside the Android. It basically converts it to the native app experience, all the jar and APK files. Till it is building, you see we have a complete Android simulator which we can load. without any hesitation. Okay, so it has found the Android simulator and it should be up in just few seconds. Yeah, let's have a breakpoint as well. You see, the app is running as a native Android app now. If we go to the counter and we click on this, you see I am also able to hit the debugger. So that means the hot reload feature is also working even when we are using a native application on a different platform than Windows. So you get a productive bug fixing and development experience here. Okay, you can get out of the app, you can go back to the app, and it will show the same UI. This is how the Blazor hybrid app can look and work. Now let's move on to the next type of architecture. Okay, so as I said in the beginning, Microsoft has announced a new architecture type in the beginning of this year, and it has already been deployed in the public previews. And on November 15th of this year, that is in next month, it will be available in the .NET 8. So what this type is? This is Blazor United. Blazor United actually overcomes all the downsides or disadvantages that we have seen previously in Blazor WebAssembly and Blazor Server, because it provides both the server socket connection as well as the WebAssembly experience inside a single app. It can be seen as a movement towards combining the powers of Blazor technologies within the .NET ecosystem. Blazor United is enabling seamless integration between client-side and server-side development. This results in more maintainable code bases, improved productivity for developers, and faster web applications. Okay, so I have one application, Blazor UI app, a Blazor United application, which is actually a preview version of the .NET 8. This application is basically developed using RC1 version of the .NET 8 framework. So if you see, it's using the .NET 8.0. And if you run this application, so right now it is only called as Blazor Web App, but in the release, the naming convention might change. So let's see how it looks on the first load. So when we load this application for the first time, what is going to happen is, to make the UI appear as fast as possible and the client should not have to wait, it will start the WebSocket connection in the background. It will actually render the UI using the WebSocket connection, and in the background, it will download all the WebAssembly related DLLs and files. Okay, so you must have seen that there was not even a microsecond of glitch. It was quickly loaded, even though if you can see there was a WebSocket connection in the background. And if we see, it has loaded all the DLLs. Okay, so next time what happens is, if I revisit this site or this web application, then it is going to load the WebAssembly version of the same application. You see, it has loaded into the WebAssembly directly. That means we can now have component wise rendering, whether server side rendering or WebAssembly rendering for the Blazor application. For example, here if you can see, we have a render mode provided. And if we go inside this render mode, we have different types of renders like server, WebAssembly, and auto. Auto means the browser will decide what to render based on the network connection and network bandwidth. This was about Blazor United. Now that we have seen all type of Blazor applications and their use cases, we should now look into the Blazor fundamentals. Okay, let's dive deep into the Blazor technology and learn about some basic concepts that we can use. For that, I have an application that I have created using Blazor WebAssembly. I will first give you a walkthrough of this application, how it looks, how it works, and then we will dive into these concepts. Okay, so the application, this sample application that I have created is a front end for the multimedia shop. You can shop for books, movies, or video games, and you can manage the products and orders as well. So let's look at different tabs. Here, if you can see, we have different books to shop for. And basically, I have used the latest Bootstrap version to make the application interactive and have a look and feel of a modern web app. So you can directly go into one of the items that you want to purchase. You have different types available. If you want a hard copy, ebook, or audiobook, you can just add it to cart. And once you add it, you will see the cart item count incremented here as soon as I add it in the cart. I can increment the copies that I want. I can remove it from the cart. Same things we can do with the movies section as well as with the video game section. Apart from that, I have also added login functionality so that user can log in and maintain its records. So here, if you can see, this is the admin user, and you can see all the orders that the user has requested. For the admin user, you can modify, delete, or add new categories. Same goes with the product types and products. Inside profile, you can change the password and you can have all the information that you want to show for that user. And you can also log out. So this is the how the application looks. Now let's dive deep into the concepts. The first concept that we are going to talk about is the how the Blazor startup works. So Blazor script start configuration can be found in the www root folder inside index.html file. Okay, so let's go back to the application. Here, if you see www root folder, and inside this we have index.html, which decides how the Blazor app should be started, whether it should be started as WebAssembly or a server. This process is automatic and asynchronous via the Blazor script. So the script name is actually consists of blazor.star.js, where start can be either WebAssembly or a server, depending on what you want. And these JavaScript initializers execute the logic before and after the Blazor app loads. They are useful in deciding how your app loads in a browser. After talking about startup, let's look at the components. Okay, so component is an element of UI such as page, dialog, or data entry form. The component class is usually written in the form of a Razor markup page with .razor file extension. So if we see in the pages, all these .razor extensions are nothing but our Blazor components. Razor is a syntax for combining HTML markup with C# code designed for developer productivity. And these components are actually a reusable structure. Okay, so it can be nested and reused. So let's see one of the examples, which is index.razor. So if you see the two different Blazor components, that are featured products and product lists, that we have embedded into the index component, and we can use it and also interact with it from our C# code. These components can also handle user events, and they can also implement iDisposable interface. That means if you have some expensive operations going on inside a component, you can dispose them when the component is going out of view inside a browser. The next concept is JS interop, which is interoperability with JavaScript. Okay, so a Blazor app can invoke JavaScript functions from .NET methods and .NET methods from JavaScript functions. These scenarios are called JavaScript interoperability or JS interop. So to look at the example of JS interop, let's go to the edit product component. Here, if you can see, we have IJS runtime, which is a dependency coming from the JS interop library, which is provided by Blazor framework by default. And we can use this JS runtime dependency to call our JavaScript code. For example, if you see here, we are calling a JavaScript confirmation dialog present inside a browser using the JS runtime, which is a JS interop. Apart from calling the JavaScript functions, we can also directly interact with the DOM elements inside a browser using this JS interop dependency. The next is routing and navigation. Blazor provides built-in router component that enables routing to Razor components and routing back from the Razor components to its nested components. So when a Razor component with an @page directive is compiled, the generated component class is provided a route attribute. When the app starts, the entire assembly specified as the router's app assembly is scanned to gather the route information for the app's components. Let's look at the example of routing and navigation. So for that, let's go to the login page, login.razor. Here, if we can see @page directive. So whenever we declare this @page directive, that means we are telling the Bootstrap that this is a routable component, and any other Blazor component can route to this component with the provided authentication. Apart from @page, let's say from inside one component, we want to navigate to another component. Okay, then we can use a built-in navigation manager library for navigating across the components. For example, here we have used navigation manager to route to the home page or to route to the different return URL if the authentication token fails. So basically we can do routing and navigation out of the box very fast and very easily. Next thing is dependency injection. Microsoft has provided dependency injection since the beginning of the .NET Core, and the case is the same with the Blazor framework as well. So we have full support of the dependency injection framework provided by .NET Foundation team. And as we are focusing on Blazor, which is an advanced topic, I assume you all would need to know about the basics of DI. It is a technique for accessing services configured in a central location. Framework register services can be injected directly into Razor components. Blazor apps basically define and register custom services and make them available throughout the app via DI. That means if we have our custom services, we can register them in the startup and then we can use these dependencies, service dependencies across the Blazor component layout within HTML as well as inside a C# code. For that, we use inject keyword. But let's first see how we register this dependency. So now if you see, I have defined some custom services like here product service, which contains all the business logic related to the products interaction. Now I need to register this service as a dependency so that I will be able to use it in any component without needing to be without taking care of its life cycle or lifetime. So here if you see, I have registered product service, category service, cart, orders, all the custom services I want to access from the Blazor components. And as soon as I registered these services in the startup, they are available for me to use inside my Razor components. For example, in the fetch data here, not fetch data, inside login service itself, if you see, I have a auth service which I have registered in the startup auth service with the iAuth service interface, and hence I am able to utilize it in the Blazor component directly by using the at the rate inject markup syntax. We can also do the same inside the C# code if we need it only inside C# and not in the HTML part. So you can just have a inject keyword and you can define your dependency. For example, iAddress service. It's as simple as that. Now you can use this dependency anywhere you want in your business logic. And you must have seen, apart from that, we are also injecting some built-in dependencies that we have not created. For example, the navigation manager, HTTP client. So the Blazor framework provides some default DI services that we can use out of the box. Some of them I will mention. The first one that is provided as a default DI service is the HTTP client. This is the HTTP client that we are injecting into our component. It provides methods for sending HTTP requests and receiving HTTP responses from a resource identified by a URI. The other service we can see is the JS interop. Okay, so where have we have seen the JS interop? You can see the edit product. Okay, IJS runtime. This is again a default dependency that we can inject into our component and use it out of the box. Then another service that we have just seen is the navigation manager, which contains helpers for working with URIs and navigation state. Okay, so that was all about the DI and how it can be used in a Blazor. Next one is the data binding. So within Razor components, you can data bind HTML elements to C# fields, properties, and Razor expression values. Data binding in Blazor allows two-way synchronization between HTML and C#. And you can use @bind markup to bind a C# variable to an HTML object. Okay. So if you see here, uh, in the product details, you can have, yeah, here if you see @bind markup syntax. So this is a HTML element, a select element, and using this bind syntax, we are binding a property or a field from a C# code. So if we see the current type ID, this is a property from the C#, which we can directly bind to the HTML element. And then the data is pushed from HTML to .NET when a component is rendered. Components render themselves after event handler code executes, which is why property updates are reflected in the UI immediately after an event handler is triggered. Another syntax for binding is for us to have a custom event handling scenarios. Okay, so for that we can look into the search page here. So here what we wanted is we have a input element, a search box, and we wanted to listen to the changes of only on input handler and not on any other keys. So that's why we have used @bind value syntax, where we are binding the search text property which is written in C# to the this element, and this property will get updated only on input custom event. Okay, so these are the different ways that we can use the data binding in Blazor application. And from the concept, last but not the least is element references. Okay, element references are the references to the HTML elements that we can directly use inside a C# code to directly interact with their functions. Usually it is useful, especially in graphical components like charts, where you need to update data on demand. Or maybe for example, here I will show you. So to use the element references, we have to use @ref keyword. If you see here, inside the HTML, my input element, I have used this reference of the input element, and I have bound it to the search input. The data type of the search input is element reference, which is a base class provided by Blazor. And then as soon as the Blazor component is initialized and rendered on the view, then I will be able to access this HTML element directly inside my C# code. So here what I wanted is, on the first render of the application, I wanted the focus to be on the search box. And that's why I directly called this focus method using the element reference. There can be different scenarios that we can have to use the element references, especially if you have different charts or graphs. Then we can manipulate these graphs and their axes or the data plotted on the graphs using the element references. Apart from these basic concepts, we also once you start developing the Blazor application, you will also come across different terminologies like life cycle events, life cycle hooks, different kind of navigation focuses, route parameters. But I wanted to cover these fundamental concepts so that it becomes easy to understand how to get started with the Blazor application. Okay. Okay, so the webinar explanation is done from my side, and if there are any questions, please do share with us. We will answer them based on the remaining time constraints. So maybe a couple of questions you can put in the window. I will wait for few minutes if there are any questions. Okay, the first question is, okay, what aspects to consider while developing the new solution? Which technology to, how to choose the technology between Blazor, Angular, and React? Okay, so when you want to develop a new solution and you want to choose the technology, we can have different aspects to consider for each of these technologies that you have mentioned. Okay, you can choose Blazor if you think, or if you are into a .NET ecosystem, you are using all the Microsoft technologies, then it can be an advantage to use the Blazor. Also, if you want to target multiple platforms using a single code base, then you can use Blazor, because Blazor supports native app development using Blazor Hybrid. It supports the web app development using web server, and it also supports SPA, single page application development, using Blazor WebAssembly. This will actually bode well for the skill set of existing team, as you are in .NET ecosystem. So that makes sense when you want to Blazor, if you based on your ecosystem. And if we talk about Angular or React, then we have basically, if you have a web application or you have a SPA application and you are out of the .NET ecosystem, or maybe you are using JavaScript ecosystem in your existing solutions, then you can opt for Angular or React. It actually depends on nature of the solution and nature of the ecosystem that your company goes into. But I think I hope I have answered your question. Okay. So another question is, how do we pass data from one component to another component? Okay. So again, if you are familiar with Angular, here is the same terminology of using the services. Apart from services, we also have WebSocket connections that we can use. Okay. And but basically, just within a single application, from component to component, it's better to use services to pass the data, because we already have a dependency injection framework provided. So you can just inject the service dependency into multiple components, and then you can have you can basically pass the data between them. Uh, yes, will it be cross-platform? Yes, it is cross-platform, and it can also be used for native app developments as well as web app developments. Okay, I think we are done. So thank you for attending the webinar. And if you have any questions, you can direct them towards us. We have also already provided the contacts with you guys. Yes. Thank you all.